Okay, we are going to be using our calculators. So go ahead and get them out. As you're going to be needing it. You do not, all this math is doable without a calculator, but you do not want to do it without a calculator. So make sure you have it. All right, number one. In how many ways can I arrange 5 books on the shelf? Anybody have a guess?
25.
25 is a guess. All right, anybody have another guess? Infinite. Okay, we have 2 guesses now. 25 and 10.
100 by 100.
All right, so let's take a look at the situation. Here is my bookshelf.
120.
5 empty slots on this bookshelf. Okay? And I am going to, here's my stack of books right here. I have 5 books, I gotta put them on the shelf. So I just randomly grab a book and put it on the shelf. How many choices do I have for that first slot? 5. Aren't there 5 books here to pick from? So I can pick book A, B, C, D, or E for that slot. I have 5 choices. That does not mean I'm putting 5 books there. I'm not. But I have 5 choices to put in that spot. Okay? So I grabbed one, I put it there. All right? How many choices do I have now for the second spot? 4. Because I already put a book here. Right? Now, what about here? How many choices for here? 3,
2,
and then 2, and then by the time I get here, there's only 1 book left, right?
factorial.
And these all get multiplied. So on my calculator, I can literally do 5 times 4 times 3 times 2 times 1. That's no big deal to do that. The answer is 120. So how many ways can I arrange the books on the shelf? 120 ways. Now, when this becomes a bigger deal is, suppose I had 20 books to put on the shelf. Now, the setup is going to be the same, except there's going to be 20 blanks, and it's going to be 20, 19, 18, da-da-da-da-da-da. Now, I can still type that in on my calculator, but that's going to take a while because there's a lot of numbers. So luckily, we have a shorthand way of describing this idea. When you start with a number and multiply by each successive lower number, we call it factorial. This right here is 5 factorial. And the symbol for factorial is the exclamation point. So 5 factorial means this. Luckily for me, that button's on my calculator, so I no longer have to type in the individuals. I can just type in 5 factorial. So here's what I want you to do. Type 5. Okay? Then press your math button. Look where my finger is. It's the button that says math on it. Go across the top to PRB, which stands for probability. And in that list, do you see the factorial button? Press it, and it should say 120. Okay, so now, what if I had 20 books? No big deal. I would type 20, math, factorial. Now, this is going to happen a lot. Did anybody do 20 factorial with me? This is going to happen a lot. Remember, what does 20 factorial mean? 20 times 19 times 18 times 17. It is a big number. So when you type it in, it's going to come out as 2.4329 times 10 to the 18. We are going to have a lot of E numbers. That's scientific notation. You see the E, everybody type 20 factorial, so you all know what I'm talking about. 20 factorial. That is a big number, a really big number. And it comes up in scientific notation And you know that because it has the E at the end. Okay, everybody see that? Those are gonna happen a lot, so keep your eyes open. Okay, how many ways can 9 people stand in a line?
360.
What'd you type in there, Caroline?
I typed in 9 factorial.
Bingo. 362,880. Are putting people in a line, is that any different than putting books on the shelf? No. So 9 people in a line will be 9 factorial. 9, 8, 7, 6, da, da, da. How many ways can prizes be awarded for first, second, and third place in a race with 10 contestants? All right, first, second, third. I got 10 random people out there running this race. How many possibilities are there for first place? 10. There's one kid that's actually gonna win, but don't I have 10 to pick from? So he can win the race, or he can win the race, or you can win the race. I have 10 choices for first place. So someone has won. Now, how many choices are there for second place? 9. And then there are 8. Now, do I go all the way down like I did in this one? No, because I'm only giving away 3 prizes. 3 people are going to win something. I have 10 choices, 9, and then 8. So that one I just type in 10 times 9 times 8. We'll come back and talk. There's a way to type this in, and we'll talk about that in a little bit. But right now, that's it. 720. Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? So every morning, go to the closet. There's 8 jumpers lined up there, and there's how many shirts? I really have way more than this, but there's 10. Okay. You know I don't care about matching, so I wear everything with everything. So I walk in and I'm gonna grab a jumper and a shirt. I'm making 2 choices. How many options do I have for a jumper? 8. How many options do I have for a shirt? 10. Multiply. I'm picking a shirt and a jumper, and we need to get used to the word "and" always meaning multiply. I have 10 choices and 9 choices and 8 choices. It's going to be a multiply. Anytime you're doing them at the same time.
How do we can afford?
You too, sunshine. Oh, that's right, yeah. Have a good time at the prom, be safe at Spark.
Thank you.
Okay, so how many outfits are possible? 80. 80 outfits are possible. Mr. Ford has 5 sport coats, 12 shirts, and 10 pairs of pants. Assuming everything matches, how many outfits does he have? Well, he's making 3 choices. So he has 5 choices for a coat, 12 for a shirt, and 10 for pants. He needs to pick all 3. He wears all 3. So it's this and this and this. So I'm going to multiply those. So he has 600 outfits. And multiply right. Now, you have a keyboard. The home row is where your fingers go when you type. And the letters in the home row are right there. How many ways can they be arranged? So, if you were going to play a prank on someone, and you could somehow rearrange their keys, how many ways could you do that? What do you think?
4,320.
How did you get that number?
By counting out those 8 and then doing factorial.
Are there 8 there? I thought there were more.
There's
than
9.
that.
Oh, 9.
It's 3, 6, 2, 8,
1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's 9.
362,000.
So that would be 9 factorial. Does everyone understand that? You got 9 blanks you're filling in now. You've taken all the letters off and you're gonna put them back. So you have 9 choices and then 8 and 7 and so on. 9 factorial. Which, what was that decimal we just, or that number we just had it a minute ago? 362,880. When we answer these questions, we will answer them with the number. So don't just write 9 factorial. 9 factorial is your setup. That's like your work. You're gonna type it in and get the actual answer. All right, how many ways can you answer 10 true-false questions? All right, now be careful with this one. It isn't 10 factorial. Think about it. There are my 10, this is like my answer sheet. So here's question number 1. How many choices do I have for question number 1? 2. It's either true or false. How many choices do I have for question number 2? 2? You only have 2 choices for all these? I'm answering question 1 and 2 and 3 and 4, so I'm going to multiply all those together. So my answer is 2 times 2 times 2, 10 times, or shorter, maybe 2 to the 10th power, 1024. So there's 1024 ways to answer it. What if I changed the question and instead of true false, it was multiple choice with A, B, C as your option? Well, A, B, C, it would be 3, 3, 3, 3, 3, 3. A, B, C, D would be 4, 4, 4, 4, 4. Okay. All right. How many ways can 4 different prizes be given out if there are 10 people in the contest? How many ways can 4 different prizes be given out if there are 10 people in the contest? Okay, so I'm giving you 4 prizes. And there's 10 people in the group. So, how many different people? I know only one's gonna win, but how many choices do I have for the winner? 10. Now he has 1. So now I have 987. And I'm gonna multiply all those together. So what did you say that was? 5,040. I'm taking someone's word for it. Is that right?
Yes.
8B. How many ways can 5 people be seated in a circle? All right. This, let's back up. How many ways can I seat 5 people in a line? 5 factorial. That's 120. That's arranging them on a shelf, right? 5 people in a straight line. Now, when you put them in a circle, it changes. Okay? I want you to think about this for a minute. Here are people A, B, C, D, and E, and I put them in a circle. There they are. When I look at this, though, these 2 pictures look different. But are they really different arrangements? Aren't these the same arrangement? Where is person A? A is in between E and B. Where's person A over here? In between E and B. So these are not different arrangements. These are rotations of the same arrangement. With circles, you can do that because there's no beginning and no end. Okay? So, when you arrange things in a circle, it's always 1 less factorial. So 5 people in a line, 5 factorial. 5 people in a circle, 4 factorial. That's a rule you need to know. When you arrange things in a circle, it's one less factorial. So if I had 10 students sitting on a bench, it would be 10 factorial. But if I had the same 10 kids sitting around a campfire, it would be 9 factorial. Okay, circles are one less factorial. How many ways can 8 books be arranged on a circular shelf? One of those shelves that spin in the library. How many ways 8 books on a circular shelf would be? 7 factorial, which is that 5040 number?
Yeah.
Are we good, folks? All right, next. How many license plates are possible if they must contain 2 letters followed by 3 non-zero digits? Okay? How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? Okay, so I'm getting ready to make my license plate. I have to pick a letter. How many letters do I have to pick from? 26. All right, so now I've put a letter down. Okay, so C. All right, now I gotta pick another letter. How many letters do I have to pick from now? 26, guys. Look at some license plates. Do license plates have repeated letters?
No.
It's perfectly okay. Yep, there's no rule that says that you can't repeat a letter, just use it twice. So there's 26 and 26. Now I need a non-zero digit. 9, 9, 9. Non-zero means anything but 0. So your answer is 492,804. Does that sound about right? How many digits are there? Can't use 0, so you're either 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. Okay? I don't need practice typing these in. I would hope you're helping me, right? All right, number 10. See number 9. How many plates are possible if nothing can repeat? All right, well that changes things. Do I still have 26 for this choice?
No.
But now, if nothing can repeat, then this has to be 25. Then for my first digit, I still have 9. But now there will be 8 and then 7. The more restrictions you put in the problem, the fewer options you have. 327,600. Number 11. How many 4-letter call signs are possible if every letter is allowed? I watch Channel 13 News because I live Chuck Lofton, and that's WTHR. That's the call sign. So some of you listen to the radio. Do people listen to the radio? I don't know if you know. I've never. Okay, well, like I don't know, WENS or WIBC. That's what they mean by a call sign. Okay, so 4 letters. WISH, Wish TV, Channel 8, I think. Call sign. Every letter possible. If there are no restrictions, how many call signs would be possible? 26, 26, 26, 26. That would include things like I, right? Every possible combination. So 26 to the fourth, 456,976. What if no letter can be repeated? 26, 25, 24, 23. Uh, 358,800. So a lot less. How about if no vowels are allowed? So I'm going back to the original problem, but I'm not allowing vowels. So here's the original problem, but I'm not, or no, that's not the original problem. Here's the original problem, sorry. Here's the original problem, but I'm not allowing vowels. Okay, how many vowels are there? 5. We're going with just the standard A-E-I-O-U, like on, what's that show? Jeopardy? Is that, no, Wheel of Fortune? The one where they get letters, not Wheel of Fortune? Yeah, so A-E-I-O-U, those are vowels. So these will be 26, 26, 26, 26. They will be 21, 21, 21, 21. What if no vowels and no repeats?
21.
Yep, 21, 20, 19, 18. And what am I doing with those 4 numbers? Multiplying them. A baseball team has 9 starters. How many different batting orders are possible? So, I am the coach. I know nothing about baseball, but I know I have these 9 guys and they all have to bat. How many ways can I put together a batting order? Thoughts on that? How about 9 factorial? I don't know anything about any of them. They can bat anywhere I decide. I have 9 choices. And then 8, 7, 6, and so on. So I can't remember what's 9 factorial. 362,880.
Yeah.
So that's how many different batting orders you could have. Isn't that remarkable? Remarkable. All right. What if the pitcher has to bat last? Now, how does that change things? Well, if the pitcher has to bat last, then I have 1 choice for that spot. Okay? Uretzi's my pitcher. There she is. So now how many guys do I have left to arrange? 8. So I have 8, 7, 6, 5, 4, 3, 2, 1. If the pitcher is batting last, then he's out of the mix. And you're left with 8 people yet to arrange. Does that make sense to you? What if the pitcher's batting last and the best hitter bats third? So what I'm saying to you is you have 1 choice for this spot. It's the pitcher. Here's your Etsy. And then Ramon's my best batter. He's here. I don't have a choice. That's where he goes. 1 person goes there. How many people are left to rearrange then? 7. So 7, 6, 5, 4, 3, 2, 1. So that would be your 5,040. That would be 7 factorial number. All right. Now, 18. This is a new concept. I have the digits, I'm allowed to use the digits 1, 2, 3, 4, 5, 6. All right? Only, those are only digits I'm allowed to use. And I am going to make a 1-digit number. Okay? I'm gonna pick one number, make a 1-digit number. How many choices do I have? 6. I'm only using these digits. So the number has to be either 1 or 2 or 3 or 4 or 5 or 6, right? That's it. I have six different numbers would be possible. But what if they're 2 digits? Think of some 2-digit numbers using these numbers. Things like 12, 32. How about 55? Yeah. So 6 times 6, 36 of them. You need 2-digit numbers that only have those numbers in them. 36 of them. What about 3-digit numbers? So like 123 or 545. 666. Which I think is 216.
Yes.
All right, so here's the new idea. The question is, how many altogether can you make? They can be 1 digit, or they can be 2 digits, or they can be 3 digits. How many altogether can I make? Well, what am I gonna do with these 3 numbers? No, I'm not gonna multiply them, I'm gonna add them. I'm gonna total them up. How many altogether do I have? When you put the word or into the problem, it becomes addition. The word and is multiply. But when you put the word or in there, it becomes addition. So the answer is whatever these added up are. 258. So there are 258 numbers that I can make from this pool that are 1 digit, 2 digit, or 3 digit. All right, I got the word Chevy. How many 5-letter words can I make from those letters? In other words, how many ways can you rearrange those letters? The word word is used loosely, they're not real words. They're 5-letter arrangements. What do you think? How many letters do you have? I heard somebody say 120. Because won't it be 5 factorial? I have 5 to choose from. I'm going to pick one, put it here, 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 here. 5 factorial. 5 letters, 5 factorial. 120. How about Precal? $720. Because how many letters are there? 6. How many ways can you arrange 6 letters? 6 factorial. How many ways can you arrange 6 people? 6 factorial. How many ways can you arrange 6 books? 6 factorial. Period. Now, I want to skip down to number 23. We're going to come back, but I want to skip down to 23. It's the same question. But what do you notice about this word? There are repeated letters. And that changes the game. Okay? Now, how many letters does that word have? So start with 11 factorial. Remember how 5 letters were 5 factorial and 6 letters were 6 factorial? 11 letters are starting as 11 factorial. But we're going to divide by the duplicates factorial. So here's what I mean. What do I have repeats of? I have 2 L's. So divide by 2 factorial. That takes care of the L's. I have 2 U's. divide by 2 factorial, that takes care of the U's. I have 2 C's, divide by 2 factorial, divide by 2 C's. Does that take care of it? Alright, let's type this in. As I was writing this down, did you hear me say divided by 2 factorial, divided by 2 factorial, divided by 2 factorial? That's the way you're going to type it in. So you're going to type 11 factorial divided by 2 factorial divided by 2 factorial divided by 2 factorial. And your answer should be 4,989,600. So your answer should be 4,989,600. Look at number 24. Same thing. How many ways can you arrange the letters of the word Mississippi? Start by counting the letters. How many are there? How many are there? 11. So we start with 11 factorial. Always start with total factorial. Now what have we got repeat-wise? 4 S's, 4 I's. So these are the S's, these are the I's. And 2 P's. There's no way to shortcut this, guys. You're going to type in 11 factorial divided by 4 factorial, divided by 4 factorial, divided by 2 factorial. And let's see what that is. And if you start complaining, I'm going to make you do it by hand, and that will not be fun. So don't complain about having to type this in. I got a relatively small number. I mean, it's still big, but not compared to that. 34,650. All right, back to number 21. How many social security numbers are possible if all arrangements are possible? So do y'all know what a social security number looks like? I hope you know. So there's 3, and then there's 2, and then there's 4. It's okay. All right. Now, we know that there are rules about social security numbers. I don't know what the rules are, but I'm pretty sure that 11111111 is not a social security number, but we're assuming that anything goes. So, if any combination is possible, how many choices do I have for this spot? Actually, 10. Because isn't 0 a digit? My number has a 0 in it, not in that spot, but it has a 0 in it. So if we're allowing everything, then we have 10, 10, 10, 10, 10, 10, 10, 10, 10. So how many social security numbers are possible?
100 million.
What'd you say? 100?
Double.
Oh, yeah, I was gonna say, no. We'd be in trouble. So that's 10 to the 9th, which is, I gotta start putting, do I have enough? So what is that, a billion?
A billion? Is it a billion?
This would be 1,000, a million, a billion, yeah.
2 million.
How many telephone numbers are possible in the 317 area code? So we got our 317, and then we have the rest of our phone number, right? So everybody's got 317. We're assuming that. All right, how many are possible if we allow everything?
Well, I thought it was 4.
Wouldn't it be just 10, 10, 10, 10, 10? All right, let's talk about that. That's 7 tens. So that's 10 to the 7th. Let's talk about that for a second. So that is 10 million. Not that many years ago, Indiana ran into an issue. I want you to stop and think about something. When I grew up, household of 8 people, 1 phone. One phone, sitting on the kitchen counter, right? That was it. So 8 people had 1 phone. Now, how many phones do those 8 people have now? 8, maybe 9 if there's a home phone, maybe more than that if there's a work and a personal phone, you know what I mean? So what happened was, we Indiana ran out of phone numbers.
That's our
So what did they do?
Added area code.
They added a new area code, because every time you add a new area code, you're adding 10 million more numbers.
So they use 10 million.
But